In this video, we're going to go over how to change decimal numbers to binary numbers. And you're probably familiar with all the decimal numbers, like you'd say like 15 or 22, but you might not be familiar with a binary number, which just consists of like ones and zeros. Okay, and when so we should say decimal numbers are base 10 numbers. So if I write here 10 to the 0 is equal to 1, okay? Any number raised to the power of 0 is 1. So if I said 2 to the 0, that's 1. 3 to the 0, that's 1. 100 to the 0, that's 1. And so 10 to the 1 is 10, which is this 110. 10 to the 2 power is equal to 100, which is 10 times 10. And 10 to the 3 is equal to 1,000, so it's 10 times 10 times 10. 10 to the 4th is basically 4 tens timed together. 10 to the 5th would be 5 tens. So when we say something is base 10, let's go through an example of, say, 127. Really, you just take this column that I just showed you. These are all powers of 10 from 0 to 4, and you write it horizontally. So there's the 10,000 right here, and then the 1,000, and the 110. And so we see 127, and we just say, okay, we put a 1 under the hundredths, because that's in the hundred position. We put a 2 under the tens position, and a 7 under the ones position. And then we just times it together. So we have 120 and 7. And we just add that together. So 100 plus 20 plus 7 is going to equal 127. So that's really what we mean by powers of 10. Because again, this is the ones, this is the tens, and this is the hundreds position. And likewise, if you had, like, say, 1,523, it's 1,000, and you have one of those. You have, in the 100 position, you have 5, and the tens position, you have 2, and the 3 positions you have, in the ones position, sorry, you have 3. You times it together, so you have 1,520 and 3, and then you just add it all together, and you get 1,523. So that's a decimal, a base 10 number. And binary numbers are base 2, okay? And so we do have that same chart of 2 to the 0. Anything to the 0 power is 1. And 2 to the first power is 2. That's 1, 2. 2 to the 2 is 4. And it basically just doubles at that point. 8, 16, 32, 64, 128. That's 2 to the 7, 7 twos. And so to convert this binary number, this is a binary. Binary numbers only have ones and zeros. 1 and 0. Okay? Because they're binary. There's only 2 states. Like in a decimal-based system, you have 10 basically different numbers. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's your 10 numbers that you have to work with. Binary, you only have 2, 1 and 0. So again, we write down the powers horizontally. 128, 64, 32, 16. This all came from this chart. And then right below it, you just put in your binary number. 1, 0. I'm just taking it straight from here. 1, 0, 1, 1, 0. And then you times it together. So 128 times 1 is 128. 32, 16. All the other ones are 0. And then you add it all together to get your 177. So this is the decimal equivalent of this binary number, 10110001. Okay? One way is is representing it in a base 10 system, and this is representing it in a base 2 system. And why we use binary is because computers understand binary. They can understand a high voltage and a low voltage. High being a 1, low voltage being 0. Okay, so how do we convert a decimal to a binary? Okay, so this was converting a binary to a decimal. Now we want to go the other way. So let's say we have 127. Okay, so the first thing we do is we look at our binary strip chart here, and we say, what is the first power of 2 that is less than or equal to 128? Equal to or less than, I should say. And the first one is 64. 128 is greater than. So we write down a 1 below it. And so we go over here to the side column, and we say 127, and we used 164 value, and then we subtract it, and we get 63, okay? And then you just repeat it again. Okay, you say, which one of these is less than or equal to 63. Well, this is greater than 63, so we have to use 32. So we just write 1 there. Boink. And we go 32. So now we got 31. So we say, okay, what's one's less than or equal to 31? Well, that's 16. 32 is greater than. Okay. And we just subtract those two numbers, and we get 15. And again, you look here and say, which one is less than or equal to 15? And there's only one, that's 8, so we write an 8 there. And then we put the 8 over here, subtract it, and we get 7. Which one's less than or equal to 8? And that's 4. And so we got a 3 here. And then 2 is the next one. And then this one's actually equal to 1, so we just put 1. You write 0. So that is, and then any spots we didn't use, we just put a 0 in. So this is the binary number equivalent to this decimal. So this is 128 decimal, and this is the binary equivalent number that the computer could understand. So you always just start with your number, find the number here that is less than or equal to that number, and if you use it, write a 1 underneath it. So we could do another example, say like 56. And okay, you look at this row here, and which was the first one that is less than or equal to 56. Well, the 32 column is that. So we go 56 minus 32, so that's 424, okay? And then we got to look, okay, which one is less than or equal to 24? Well, that's the 16. So we put 16 in here, and that gives us 8. And 8 is exactly it, okay? And then we're done, okay? So we didn't use any of the other positions, so we just write 0, 0, 0, and then 0, 0, and 0. So 56 is the same as the binary number 0, 0, 1, 1, 1, 0, 0, 0. Okay? Okay, let's go to the next one. Okay, an alternative method to convert a decimal to a binary number by successive division by 2. So I showed you this method to convert to a binary number. Whoops. How to convert a decimal to a binary. But there's also another method here that we could do, and it's just by dividing by 2. So you take your number, let's say 127, and you divide it by 2 until you get down to 0. And so that would be 6 is 12, 3, okay? And so you write here over here 63 remainder 0, okay? And then we take that 63 and divide it by 2, and that's going to be 3, so that's 6 and 1. So now we have 31 remainder 0, okay? Then we take the 31 and divide it by 0. 1, 2, 1, 1, 5 is 10. So now we have 15 remainder 0, okay? Oh, I'm doing, sheesh. I did this all wrong. I'm putting remainder 0 when they were all remainder 1, actually. 1, 1, and 1. Sorry about that. And then we go 15 and divide it by 2. So that's going to be 7, 14, 1. So that's 7 remainder 1. And then we divide 7 by 2. That's going to be 3 remainder 1. And then we divide 3 by 2. So that's going to be 1 remainder 1. And then we divide 1 by 2. So that's going to be 0 remainder 1. And once you get to 0, you stop. And how you read your binary number is you read it from the bottom up. So we start out at this number. So we go 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7. And we didn't have an 8th position, so I'll just put 0 there. So if we go back over here, you can see 127 when we use the other method came out to 0 and all the rest 1s. And now when we're doing it by the alternate method of successive division, we get 0. But let's try the 56, okay? So we're going to do 56 by successive division by 2. So we write down 56 as our decimal that we want to convert to binary. 56 divided by 2. That's going to be 2, 4, and 1, 6, and that's going to be 8. So that's going to be 16 and 0. So that's going to be 28. 28 remainder 0. Then we take the 28 and divide it by 2. And so we have 14 remainder 0. And then we take our 14 and divide it by 2. And we have 7 remainder 0, okay. Then we take our 7 and divide it by 2, and we're going to have 3, 6, 1. So we have 3 remainder 1. And then we take our 3 and divide it by 2, and we're going to have 1, 2, 1. So we're going to have 1 remainder 1. And then we take our 1 and divide it by 2. And so we're going to have 0 remainder 1. And now we stop because we have our binary, we got to 0. And again, you read it from the bottom up. So now we have 0, from the bottom up. So from the bottom we have, and we're just reading the remainders, not anything else, just the remainders, okay? And so you have 1, 1, that's this guy and this guy, 1, and then the 3 zeros, okay? So it's 1, 1, 1, 0, 0, 0. And so that's our binary number, 1, 2, 3, 4, 5. And if we wanted to add the 2 leading zeros, we could to make it 8 bits. So if we go, so this is our 56, and so it was 3 ones and 3 zeros. And if we go back to our old method, let's see, 56 was 3 ones and 3 zeros. So we got the exact same number, which is good. Okay. Now in the puzzle, what you had to do was take a binary number and then convert it into its decimal equivalent. And then you go to this ASCII table. So let's say, let's go to 56 here. Whoops, sorry, not 56. What was that one? This one was 177. I don't know if that, no, that's too high. So what you would do is first you would do the conversion from binary number to a decimal. Then you look on this chart. Let's say you had, actually, let's just do one right here. Let's copy this here. Copy. And then move this up a little bit, and then paste it. And let's say you had the number, the binary number 0, 1, 0, 0, 0, 0, 0, 1. Okay? That was your binary number. And then by using the method that I showed you, all you have to do is just times these two. So you got 64 and 1. The rest are zeros. And then you just add them together, which equals 65. Then you go to 65 on your chart, and that tells you that that is an A. And so that's all you have to do is convert from binary to decimal, and then look on the chart and say, okay, whatever number I got corresponds to this letter in the alphabet. And that's it for converting decimals to binary and binary to decimal, and then converting your binary number to a decimal to an ASCII code, and which was what the computer understands. The ASCII code, it has that table built in.